Hi, so welcome everybody. My name's Alan. I'm moderating this session. And so welcome to Cloud and DevSecOps Z Days. I hope you're really enjoying the different talks, or if you're watching this afterwards, please look up some of the other talks and benefit from those. Today we've got Daniel Rodriguez talking about Azure Arc for hybrid and multi-cloud solutions. I've had a little preview and I'm really looking forward to the finished version of the talk and what he's got planned. We are going to have some questions. Be prepared to type those into chat. And as you may have just caught on the screen, we'll have a prize for what I think, very biased view, what I think is the best question. Try not, if possible, remember to say who you are as part of the question. Don't leave it anonymously. And we're aiming for about 40 minutes of talk and 15 minutes of questions. So over to you, Daniel.
Okay. Thank you, Alan.
Yeah, you're good to go.
Okay. Thank you everyone for joining into this presentation. I will talk about Azure Arc aspects and capabilities. So let me share my presentation. Is the presentation now showing?
Yeah, all good. Thank you, Daniel.
Okay, excellent. Okay, so these are the contents I will follow, starting from basis and going to the architecture. And at the end, I will take a look to each of the services. So let's start. What is Azure Arc? For answering this question, I'd like to mention about Microsoft Hybrid. Microsoft Hybrid are Microsoft services with the purpose of creating hybrid and multi-cloud solutions. And Azure Arc is part of these solutions. With Azure Arc, you will be able to connect and manage on-premises and other cloud resources as well. It will help on solving cloud problems by administering all the resources from a single point, the Azure portal. Think about the migration, for example. Many customers are migrating to Azure right now. Using Arc, you will be able to administer all foreign resources as an Azure native resources. All the resources you connect with to Azure with Arc will belong to a subscription, to a resource group, and each resource will have a resource ID. To provide an example about what's good having this setup, imagine you have multiple applications running into containers. Something inside GCP, something inside AWS, something on premises, and something on Azure. With Arc, you will be able to manage all of them from one single place. Extending Azure Resource Management to any infrastructure provides these main features: connect and manage foreign Windows and Linux machines, connect and manage Kubernetes clusters and enforce its configurations across non-Azure environments, use policies in order to keep compliant, and in addition, Azure Arc provides data services. This feature enables the deployment of database managers. We'll check more details later. So we have 3 Arc services: Arc for servers, Arc for Kubernetes, and data services. Soon we'll check the specific details about each of them, as well as providing demonstrations at the end of the service, of each service. I won't create anything from scratch. I already have the demo set. And this is because commands sometimes take more time, sometimes commands hang on, and in this case, Kubernetes is used a lot. And then it's a matter of removing namespaces, recreating stuff, removing deployments, etc. And we don't have the time for doing that. So let's move on to the architecture. I want to show you this diagram. Light blue squares represent Azure Arc technologies, and right side column represents Azure Cloud. Connected resources will be able to make use of Azure Resource Manager features, all of these features. Now, by using the Arc resource providers, customer resources will connect to Azure Cloud, as we can see. Each of Arc services need an agent in order to make that connection. Arc for Servers agent connects using the Arc for Servers RP. Arc for Kubernetes agent connects using the Arc for Kubernetes RP, and the same for data services. It gets connected using the data service resource provider. Now, between Azure Data Services and Kubernetes, we can see something called the Azure Arc Data Controller. Data services need a Kubernetes cluster in order to deploy database instances. The piece that makes this possible is the Arc Data Controller. It gets deployed into Kubernetes, and it uses a data agent in order to deploy DB instances. Therefore, you cannot deploy databases without Kubernetes and a running controller. Finally, at the right side, we can see that all of the common tools can be used to manipulate databases, Kubernetes, and server resources. Tools you can use: Azure Data Studio, MySQL, SQL Server Management Studio, a command line for manipulating Kubernetes, the same for Linux. You can RDP to Windows, SSH to Linux, and nothing special. Okay, let's move on. And there is something really important to mention. Azure Arc for Kubernetes and data services are still on preview mode, and there are technical limitations. For example, not everything can be done through the portal. Some stuff are CLI available only, and for data services, you cannot see resources in the portal. Regarding servers, the service is now publicly available. Anyway, you cannot connect all of the operating systems, but the most common ones are supported, like Windows, Ubuntu, CentOS. On the other hand, supported regions are very limited for now, but Microsoft will add more in the future. So, the first service, Arc for Servers. Arc Server Management brings to us the capability to have foreign machines connected with Azure. In order to get them connected, you need the Connected Machine Agent. This agent will help us connecting both Windows and Linux machines, and the task can be achieved through PowerShell or Azure CLI. Then, once a machine is connected, the agent will send a heartbeat every 5 minutes and will disconnect or reconnect machines as needed. The time can be changed, of course, by modifying the configuration file. Main Arc for Servers features are organizing resources, using the Azure portal, assigning Azure policy guest configurations. These policies could be used for many reasons, like checking software versions for compliance or having certain software versions installed. Another feature is monitor and logging data, which includes performance metrics like memory, CPU, and disk inputs and outputs. Just to mention an example, onboarding can be done using personal IDs, but it's also possible to use Azure Active Directory Service Principal as an identity. Actually, this is recommended when working with many servers. You won't use your personal ID when working with a bunch of servers. So let's move on to the servers demo. Unfortunately, I don't have the on-premises server anymore, but I will show you the Windows server that runs on GCP. The important thing to show in this diagram is that there's a two-way communication towards Azure, thanks to the connected machine agent. So let's take a look at the server that's inside Google Cloud. Here I am inside Google Cloud Console. Let's move on to the compute engines, VM instances. And this is the one, the name. Okay, it has many features in here, including the external IP, which I'm gonna use to get connected. The server image, it's a window. Okay, so let's get into the server. I'm gonna RDP to it. Let me open the RDP tool. Okay. And here I am inside the machine. This is the installer that installed the connected machine agent. It gets downloaded automatically by using this script. I executed this script, and as we can see in here, it successfully got onboarded to Azure. So we can see in here that's the same IP address. Now let's move on to the Azure portal. This is a resource that it's now recognized by Azure using Azure Arc. Here we have the operating system. Here we can see some properties. And here we can see the resource ID. It's now an Azure resource. It has a resource group, subscription name, subscription ID. And if I go to Insights, which actually it's a feature that I previously enabled, and in order to enable it, it's very easy. All you need is a log analytics workspace. The agent gets installed automatically. And in here, we can see two tabs, performance and map. In map, you can see some of the processes, including some GCE, Windows agent, Google agent, Microsoft stuff, okay, open ports. But the cool feature is inside performance. In the performance tab, we can see CPU utilization, available memory, disk stuff. So it's a very cool feature to have your servers monitored through Arc, your foreign servers, right? Okay, let's go back to the presentation. Next service is Arc for Kubernetes. It provides a way to organize, secure, and govern Kubernetes clusters that reside in any on-premises or multi-cloud infrastructure. Then, once a cluster is attached to Azure with Arc, you will be able to deploy applications and apply GitOps-based configurations. GitOps is a methodology that provides a way to deliver application changes using Git and continuous deployment approaches. GitOps methodology lets us manage our clusters and applications. The GitOps workflow is used by Arc for Kubernetes, and the result is delivering Kubernetes-based applications that can be always matching the source repository. Arc for Kubernetes deploys agents that are responsible for this connectivity, also logs and metrics, and, very important, watching for changes. An agent called config agent is the responsible for watching for those changes, and it assures that the state of the cluster always match the Git repo state. Now, GitOps configurations utilize a single source of truth, and thanks to the configuration as a code, it's possible to get rid of local configurations. Therefore, you can apply them directly in the repository. Git files can contain any valid Kubernetes resources. Now, the demo. The requirements in order to make use of this service are a running Kubernetes cluster with admin permissions, Azure CLI with Arc for Kubernetes extensions, OpenTCP on ports 443 and 8418, and Helm 3. At the left side, we have the diagram of the demo. The bottom big square represents a GKE Kubernetes cluster. It runs on Google Cloud Platform. It holds an application that can be reached by the front end. The code gets pulled from a GitHub's repo, and the front-end Docker images will be taken from Azure Container Registry. I don't remember if it's Azure Container Registry. Maybe it's Google. I've been playing with both container registries, but it's the same behavior on all the container registries. Even if you have your own container registry setup, you can use it. Then the agent will be connected to Azure Cloud by using the Arc for Kubernetes resource provider, as we can see in here. Okay, so let's move on. I'm gonna open a terminal. I'm gonna SSH to a server. This server, I will use it to get connected to the Kubernetes clusters. So let me, first of all, I want to show you the cluster that we have connected with Arc. Okay, this is the one. The information includes location, name, resource group, ID, and some other information. So now let's select the front-end cluster in order to check its contents. No. This is the command. Okay, it switched. And now let's see the namespaces. These are the Kubernetes namespaces. Azure Arc contains the agents responsible for the connection. AppConfig contains the configuration of our application, and bank app contains the application. So let's take a look at their pods. Okay, I'm showing the pods for AppConfig, Azure Arc, and bank app. And one of the most important agent, as I already mentioned, is the config agent. And we can see that just in here. Okay, this one is the one that looks for changes in our configurations. And Azure Arc is more complex. You have the controller. Actually, here's the config agent. The config agent will look for the configurations, and here is the configuration. Okay, and now here is the application. So using the configuration that I will show, also using the portal, Kubernetes and Arc pulls all the information and deploys the application. Okay, so let's describe this AppConfig pod. We have a lot of stuff in here, but one of the most important things is these arguments. You have all of these arguments. You need to tell the configuration that you have them in there. For example, here is the Git URL. So here is where my application resides. Okay. So let's move on. I'm going to show you the configuration itself with this command. Now we can see the configuration that the Kubernetes Arc for Kubernetes is using. So here we have also the repository URL, resource group, and the ID. Okay. Only for informational stuff. Now let's access the application. It is working. It's a running application, completely running and fine. And then let's go back to the terminal. I'm gonna remove a pod in order to show you how it gets created automatically thanks to the Arc for Kubernetes agents. Sometimes it gets recreated very fast. Sometimes it takes more time. So it depends. I'm gonna remove the front end. So without the front end, I won't be able to see the application. Okay. Okay, let's wait for its removal. And the removal won't take longer, usually. Okay, it got deleted. And then if I, maybe it got recreated right now. Yeah, here we can see that now the age, it changed. Now the age of the front end is only 50 seconds, 15 seconds actually. Now, if I go to the application, it should be running. And yeah, it is running. So with this enforcing configurations feature, it's possible to have our configurations and our applications always running. And using the most recent version, that's something really important. For development, it's something really, really cool. Okay, and going again to the Azure portal, let's take a look at the GCP cluster. This is the Azure Arc onboarded cluster. And we can see some information, Kubernetes version. We can see that it's a Google Kubernetes engine. And let's take a look at the properties. Here we have the Kubernetes version also, the total non-count, resource ID, name, blah, 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 just like the server, right? And now, if I go to the policies, some policies can be applied to here. You can assign initiatives, and this feature is also available for servers. Now, if I go to Insights, here I can see node CPU utilization, node memory utilization, node count. I can see node information. 4 nodes are running. I can see controllers information and containers. So very nice features from Arc. Then in here, inside the configurations, this is the configuration that I showed you using the command line. As we can see, we have the repository URL, we have parameters that they are the same parameters that we saw on the command line interface. And with this, we conclude the Kubernetes part. Let's go back to the presentation.
While Daniel is switching back to the presentation, just a reminder to everybody to feel free to put questions into the Q&A while Daniel's talking, and I'll publish them and then we'll try and answer them all at the end. Sorry, Daniel, thanks.
Oh, no, thanks. Thanks for the reminder. Okay, so next service is data services. This service enables the run of data services on premises, at the edge, or in multi-cloud infrastructures. In order to deploy database instances, a Kubernetes cluster is needed, as I already mentioned. The data controller needs to be installed in there. Data controller provides the integration from Azure to the cluster. Without a Kubernetes cluster and the data controller, you won't be able to deploy data services. So, Azure Data Services main features are provisioning, monitoring, backup, high availability, and elastic scaling. Data services have been tested on Azure Kubernetes Service, Google Kubernetes Engine, Elastic Kubernetes Services, and the service from AWS, and OpenShift. In this diagram, we have a representation of Azure Arc data services. On top, we have the Azure Cloud, which is in communication with the data controller. It makes the integration and provides all of these capabilities, scaling, backup, updates, etc. And then we have the DBs that are deployed using the data controller, these ones. At the end, all of the databases reside on a Kubernetes cluster, no matter where the Kubernetes cluster is. Okay, let's move on to the demo. Basically, it's a Kubernetes cluster connected with Azure Cloud. Thanks to the Azure Arc Data Services resource provider and the Arc Data Controller, deployment images are taken from the Azure Container Registry. At the end, we will have an SQL instance and a PostgreSQL instance deployed from Azure. If each of the instances have their own databases, for now, this service only supports Azure SQL and PostgreSQL. Then at the right, we have the official requirements and the tools that are needed. AC data is the command that manipulates data services. For this service in particular, a lot of RAM is needed, okay? So be careful with that. Let's start with the demonstration. For this demo, I already have the data controller installed with database instances already deployed. I've been using CLI for the deployments, but for this demo, I used the Azure Data Studio just to show you a little bit about the capabilities of this tool. But first, let's check the Kubernetes cluster. It's a different cluster, so let's switch to it. Oh, somehow it got stuck. Let me try with a different terminal. Okay, I'm inside the data services cluster. Let's take a look at the namespaces. Here we have the namespaces. Arc is the namespace that contains the data controller. Let's take a look at its spots. Okay, we have many pods in here. And here we can see the ones that holds the database instances, Postgres and SQL instance. Now, as I already mentioned, I used Data Studio to create databases this time. Even I created the data controller using Data Studio. So Data Studio offers a way to deploy and manage our Arc database instances, among other things. This is the section, new deployment. And here we can see you can deploy SQL Server, SQL Server in a container, Azure SQL, but these ones are the Arc related deployments. Azure Arc Data Controller, Azure SQL Managed Instance, and PostgreSQL Instance. So these deployments provide, these are scripts, basically. In this example, I already opened the script, but here we can see all of the contents. In the case of the deployment of the Arc data controller, it's 7 steps. So it creates the helper functions. All of these you can modify whatever you want. Then it verifies the prerequisites. Step number 2. Step number 3, verify Kubernetes context. Here we can see the actual command that was executed. Step number 4, specify the environment configuration details. Initialize the creation of the data controller. Actually, we can see in here that the data controller was deployed. Some information, the endpoint and the port. Step number 6, check namespace, pod, and persistent volume status. Here we have the code and the output. These are the namespaces, the PVCs, persistent volumes. And at the end, it gets connected to the data controller. As we can see in here, data controller ready. Okay. The same I did for the instances. This is the script, and this is the script for the PostgreSQL hyperscale. Now, at the left, we can see some connections. Using Data Studio, you can get connected to servers, to Azure, and repositories. In here, we have the source control. But in this case, we can see the Azure Arc controllers. And you can manage them. For example, this one, the only one, right? This is the data controller, and these are the DB instances. Here we can see some information. Let's take a look at this one. The same for Postgres. Okay, one of the cool features about this, let's go to this one. Because in here we have more databases, and here we can see some service endpoints. For example, this one were created automatically. Kibana and Grafana. Kibana is for viewing logs, and Grafana is for viewing metrics. They are actual applications you can use. Here's Kibana loading. Here's Grafana loading. Let me enter my credentials. It's the same user that I used for the creation. Grafana is now ready. As you can see, we have transactions, we have batch requests, and other stuff that will be really helpful in order to monitor your DBs. In Kibana, you can see your logs. I'm not involved with this tool, so let's go back to the Data Studio. In here, we have the connection strings that you can use in order to get connected to the DB instance, just like any other database. Okay. And then using the CLI, you can take a look at the instances also. For example, with this command, I can take a look at the SQL instances. This is the server endpoint. It is ready. Now with this, another command. Oh, man. I can list the Postgres instances. We can see the name, the state. And with this command, we can check for the endpoint. Oh, I'm not logged into the Arc controller. So let's log into it. Namespace is Arc admin, and my password. Okay, as we can see, I got logged into. Now let's check the endpoints. And we can see here the endpoint URL. Okay, so I can use this URL in order to get my connection into Postgres. Let's test it. Password, and I'm in. Okay, now you can do whatever you want. For example, listing your databases. I can see 4 databases. Oh, I thought it was empty, but we have 4. At least you have this one, right? This one is the default one. And you can create another DBs, for example. Create database, first database. Not first database, right? Okay, it was created. If I list again, we can see here, not the first database was created. Now, the reality is that these commands sometimes fail as the preview is still going. Now let's go back to the presentation. I added this competitors slide. Same as Microsoft, Google, and Amazon have their own solutions. This table provides an overview. Anthos is oriented more to modernization and containerizing applications, and AWS Outpost is focused on managing on-premises. Azure Arc is the only one that supports data services and policies, because in Anthos, I know that you can apply IAM policies, but I am not sure if you can apply, for example, configuration policies or something that manipulates your resources, your foreign resources. So, okay. In conclusion, Arc is a cool new tool that you should check. It provides many features to on-premises and other cloud provider resources. If you get involved with it, you will get involved not only with Azure, but with other cloud providers as well. It's a great experience having servers and Kubernetes clusters from anywhere attached to the same tool, not to mention database services. Okay. Okay, this is everything from my side. Now we can move on to the questions section. I'm leaving here my personal information, just in case you need to contact me.
So thanks so much, Daniel. I mean, maybe while while you're answering questions, it might be worth putting the camera back on. So we've got a couple of questions that have come in. If anybody else has questions, feel free to type them into the Q&A, and we will we'll seek to answer them. So first of all, I mean, Daniel, really interesting talk. I always think it's great when somebody else is experimenting with a new product and can give us the lowdown on it. I find that really interesting and a really great introduction. So hopefully others feel the same about that. So let's dive into the questions, and yeah, remember that I get to choose who the best question is. At the moment, it's a 1 out of 2. Be great to have a few more questions. We've got about another 15 minutes we can use if people want more discussion or questions. So please keep the questions coming in. So let's take Matteo's question first. So I think essentially Matteo is asking, he says, which component tool service allows Arc to manage networking communications among the different cloud providers or data centers? I'm not sure whether I think from my point of view, I'd be quite interested in how is that network connection made? Does it, how do you actually physically do the connection in terms of how do you set that up?
Server, the connections are done using the TLS 1.2 protocol. Same for the clusters. Yeah.
Okay, so it's over the internet, is it?
Yeah, exactly. So
Okay.
if you have this protocol enabled, actually it could work if you are using a different protocol. But well, you will have your cluster as secure as you wish. Sorry. So if you enforce the communication using 1.2 ciphers usage, you will provide more secure data traffic over the network. Yeah.
Okay, I mean, Matteo, if that answers your question, then great. If not, feel free to type in a supplementary, and we'll circle back to it in a minute. Okay, this could be a short question and answer session. Still no other new ones, so we'll go to Valerio's question. Valerio, in case I picked yours as the best question, I would need an email address or some contact details. So do come back to me with that, so I have the liberty of choosing 1 out of 2 instead of 1 out of 1. Anyway, Valerio's question is asking around least privileges, and effectively he's saying, I have least privilege pattern enforced for policies on AWS, and so then if I want to use Arc, would I risk downgrading my security, or rather my RBAC? So could you just perhaps talk a little bit about security, and in the sense of role-based access control and least privileges when you're going cross-cloud like this?
Well, actually, the connection is done from your resource, your AWS resource or your GCP resource towards Azure. It's not from Azure to your resource. So it depends on if you have like, for example, everything blocked, you won't be able to communicate with Azure. For example, for servers, you need the 443. Okay, so it's like if you need that port open, and usually servers, I mean, it depends on your local configurations. It's not something that you will manipulate from Azure, right?
Yeah, but let's try and extend the conversation if we can a little bit, Daniel, on that, because and I'm sort of acting as a proxy for Valerio here, so I may have the wrong angle, but so feel free to type a follow-up, Valerio. But if I have some role-based access controls and policies in place in AWS, yes, AWS connects out, but when I connect out, what privileges do I then have from the Azure end to do deployments? Do I get the privileges of the service that connected out, or quite how does that work?
No. For example, in clusters, well, you need admin privileges using the cluster. I mean, of course, if you have a user that it won't be able to modify your cluster, you won't be able to create the data controller. So therefore, you need admin privileges in order to modify. Yeah, okay. I mean, it's so not like not something that I can provide a lot of information.
No, and of course, some of these services are still in preview, and some of the role-based access control could well be something that comes in a little bit later. But so you've done all of your experimentation effectively as an administrator.
Yeah. Actually, right now the tool is running really fast. This month, some plugins were released. Actually, it's something that I will need to check. I will check that in a couple of weeks more. And yeah, at the beginning was like, hey, you cannot do that from the portal. Regarding servers, it's like you couldn't access the insights that I showed. Even it was a mess onboarding the server. It was really difficult. And for example, data services, they are new commands, so they changed. And actually, that's why I decided to test the Azure Data Studio, because the deployments are also new, the Arc deployments. And it's the first time I use that tool, and it's a really cool tool. Another questions?
As I've said, please come back with follow-ups, Matteo or Valerio, if we haven't fully answered it. An anonymous question now. I'm afraid anonymous doesn't allow you to win the best question prize. So please provide some contact details, and you, Valerio, if you don't mind. Okay, so the anonymous question: how can Azure Arc help to a small business like a home audio studio startup? I suppose the implication here is for a big company, a bank, as you demonstrated, Google's pretend bank, you can sort of see that hybrid cloud scenarios are becoming quite common. And so Arc could be a really cool tool there. But what about a smaller business? Why might they want to use this?
Well, if it's a small business, I don't think you have a site and on-premises stuff. So Arc is more dedicated for something maybe big. But in this case, maybe you have some stuff stored in GCP or in AWS. In that case, you could manipulate your resources from Arc, and I don't know, make what you want. But what I suggest is to use this tool if you have a complex environment, because that's the best thing that the tool offers. I mean, you have lots of servers on premises, you have lots of servers on Azure, and you have lots of servers somewhere else, just to mention something. So in this case, it will be really useful because you will be able to manage all of the things, all of the resources, all of the servers, or even your applications, your Kubernetes applications from one single place, the Azure cloud. Yeah, in a nutshell, that's it.
Yeah, it's single management. But if you had something, I mean, I think you sort of answered it there, Daniel. But if you had something fairly simple, but you had a service you wanted to take from, say, Google, as you demonstrated, and a different service that you wanted to take from Azure or AWS, would you use Arc to simplify the management?
Well, actually, I don't recommend to have something small running on Kubernetes, because Kubernetes is something really complex. I mean, you need a lot of stuff running there. So if you have a small application, a single application, I suggest maybe to use virtual environments, for example, with Python or something more. But because Kubernetes is like very big, and it's not a good approach to have something really small in there. It's more focused to big stuff, and when you have multiple applications, because this way you will have lots of applications split into containers. This is more talk regarding Kubernetes itself.
Okay, so Valerio has come back with a follow-up. Thank you, Valerio, saying he's not really talking about the networking, and I suppose he means the connectivity as well. It's more related to the granularity towards resources of each microservice in its own cloud. But I mean, is there any more information you've got on RBAC and so on, and the permissioning and so on in this? The policy?
Yes, I think I got what you are talking about here. If you are not talking about networking, I misunderstood. Sorry about that. But if it's related to granularity towards resources, okay, then for example, in the case of servers, you won't modify, for example, the CPU, how much CPU you have, or how much memory you have. No, that's not something that is something that you will do through your cloud provider, through Google Cloud or through AWS, even in Azure. In this case, it's more like installing things on the computer, installing software versions, checking software versions, checking if service is running, even starting services or shutting down services, stuff like that. It's not like modifying the resource in the hardware way. Okay, But in this case, you're speaking about microservices. So it sounds to me like you are referring to Kubernetes. And yeah, using Arc and having admin privileges, you will be able to modify all of the pods, and therefore, because the microservices runs on the pods, right? So yeah, it's something you can do. We cannot hear you, Alan.
Sorry, my mistake. I was just saying thank you for that, Daniel. And as you said at the beginning, some of this is in preview. Daniel's been exploring in a fascinating way some of the things you can do with it. I'm sure, like many Microsoft products, it will develop rapidly. It looks like it has a great future to me. So thank you for that overview, Daniel. I don't have any more new questions coming in on my screen. And we've only got a couple of minutes left of the time. We were due to finish at 5 to the hour anyway. So I think we'll close it there and say thanks again to Daniel for a very interesting talk and the walkthrough and the demos. I thought they were going to go wrong at one point, but then it worked again. All the best demos have some failure in and some. And
I thought exactly the same.
some catch from the speaker. So I was pleased it's not just my demos. Oh, we have one more question. We have one more question. Haven't you compared Arc with Anthos, which is Google's competitor?
Yeah, as I mentioned on the competitors slide, it's something really. I mean, it offers kind of the same, but this Anthos is more focused on modernizing. So if you have something that runs on your local computer, or I mean, a legacy application or something. Well, actually, I'm not sure if a legacy application, but an application. I'm not that involved with Anthos. Just to say that. But if you have an application that is not containerized, you can containerize that. So it's modernizing. It's modernizing. It's deploying applications. It is not focused on servers. And it's more like applications and using Kubernetes.
Okay, thanks for that view, Daniel. Okay, so I think we're going to close it there. Valerio or the anonymous questioner, if you would like to put your email address in somewhere that I can see, then you have a chance of winning the best question prize. But without that, we can't get back to you. So we don't know who you are to get back to you should you win. So thank you so much, everybody. I'll just I think we'll close there. And thank you again to Daniel and to those that have asked questions.
Thank you.
Thank you.
Alan, thank you, everyone.
Thanks.